Hey, all, today we're going to continue talking about measures of position. We've talked about percentiles, we've talked about z-scores, standard scores, and today we are going to talk about quartiles. So as you might be able to tell from the name, quartiles break our data up into 4 groups. 4 equal groups, so we break them up into 25%, 25%, 25%, and 25%. And so finding a quartile is similar to finding a median. We have 2 quartiles. We have the first quartile, which we call Q1, and we have this third quartile, which we call Q3. Q1 is after the first 25% of the data. The median is right in the middle, cutting the data in half. Q3 is at the 75th percentile, and then so now we have 4 different groups that these 3 values break up. So if we're looking at our data here, I did do it from least to greatest. We have 10 data points, so the median will be right in the middle. So if we put this data into Excel or into a calculator and we asked it to find us the median, it would give us a median of 18.5. So we have broken the data up into 2 equal groups. Our Q1 is going to be on the lower half of our data. So now if we look at just the lower half of our data, Q1 is the median of that data set. The median of this group of data is the number in the middle. So our median value for this lower half of our data set is the value right in the middle. That's 15, and we call that Q1, quartile 1. If we look at the upper half of our data, the value in the middle, the median of that upper half is going to be our Q3, quartile 3. So our Q1 value, our quartile 1 value here is 15. Our median is 18.5, and our quartile 3 is 22. And we can calculate that using Excel if we want to. So here we have the data set. We can find the median. We can say equals median of these data points. And there we get our 18.5. For Q1, we can say equals median and then take the median of our lower half of the data. It's those 5 data points. Q3, we can say give us the median of the upper half of the data. And there we have the same values. Obviously, it's better to use a piece of technology when your data set is very large. This is a small data set, so it's pretty easy to spot the median of the data set and then the medians of both halves, which are our quartiles. We can use those quartiles to find this measure of range called the interquartile range. Interquartile range probably indicates to you that we're going to be using our quartiles. So we have our Q1 from the first page was 15, and Q3 is 22. Our interquartile range is the range between Q1 and Q3. So we found range earlier in data sets. The range was the maximum minus the minimum. It told us how spread out our entire data set was. Interquartile range tells us how spread out the middle 50% of the data is. So our Q1 and Q3 cut off the middle 50%. It's good to talk about interquartile range when we want to talk about how spread out data is if that data set is skewed, meaning it's not symmetric. Because typically that middle 50% is not going to be part of the tail in a skewed data set. It's going to be closer together. So if we want to find the interquartile range, which we simply refer to as IQR, we find it much like we find the regular range, except we use the quartiles. We're going to take the biggest quartile, Q1, and subtract the smallest one. To find regular range, we would do the maximum minus the minimum. Here we're finding the range between the two quartiles, and so we do Q3 minus Q1. And one of the things that that IQR measure does that's really nice is it allows us to determine, do we have any outliers in our data set? Outliers are unusual points. Outliers are values that are extremely high or extremely low when compared to the rest of our data points. Those are the values that end up skewing data sets. So if I were to have a data set that looked like this, skewed to the right, or a data set that looked like this, skewed to the left, the data points that were either far right or far left are probably or potentially outliers. They are skewing our data sets, and we can figure out or determine if they're outliers by using the following procedure. We are going to essentially build fences. Any values outside of those fences we will consider unusual, and therefore we will consider them outliers. So if I look at this data set, I have 8 data points. My median is there somewhere in the middle. And if we did this on Excel, we would find that the median is 14. It's just the number in between those two data points. Q1 is going to be right here, the median of our lower half. Q1 is going to be right between 6 and 12, which is 9. Again, you can calculate this on Excel if you want to. Q3 is going to be in the middle of our upper half. Between 18 and 22 is 20. And we can calculate our interquartile range by doing Q3 minus Q1. That's going to tell us how spread out is this middle 50%. And what we want to do is now set up boundaries or fences, whichever you want to refer it to. We're going to find a value to the left on our lower end and a value to the right on our upper end that will cut off where we have points that are not unusual. The way we do that is by taking our, so we're going to build a lower end fence or boundary. We're going to take Q1 and subtract from it 1.5 times our interquartile range. In order to build our upper fence, we're going to take Q3 and we're going to add to it. So we're going to be over here to the right, 1.5 times IQR. So it would be a good idea to calculate what 1.5 IQR is. So we're going to take 11 and multiply it by 1.5, and we're going to get 16.5. So to get our lower fence, our lower boundary, we're going to take that Q19 and subtract 16.5, which is going to give us negative 7.5. So over here, we have a fence or a boundary at negative 7.5. Any data point less than that would be considered an outlier. Of course, we don't have any of those because the smallest data point is positive 5. So there are no points that are unusual on the lower end of this data set. We could take our Q3 and add to it 16.5 and get 36.5. So we build a fence somewhere in here at 36.5. Anything above that value is going to be considered an outlier. Therefore, this data point of 50 is considered an outlier. It is 1.5 times IQR plus Q3. It's bigger than that. Therefore, it's an unusual point. This data set is probably, in fact, I guarantee if we did a histogram, is skewed to the right because of this data point that is much bigger than all of the rest. So I want you to try these two problems. For the first one, I want you to find Q1 and Q3, and then calculate the IQR. And for the second one, I want you to use the process I just used on that last page to determine if there are any outliers in this data set. These are not numbered from smallest to biggest, so you want to put them in Excel and sort them from smallest to biggest. If you need help while you're working through these, please do ask for help. Pause right now, try these two on your own. It's okay if you get them wrong, then press play, come back and check your answers. So go ahead and check your answers here on the first one for Q1, Q3, and IQR. And for the second one, you needed Q1, Q3, you needed the IQR, you need to multiply that by 1.5. We're going to subtract 19.5 from Q1. We're going to add 19.5 to Q3 to determine our lower and upper boundaries. And because our lower boundary is 66, this data point of 65 is just outside of that, and therefore we would consider it an outlier. If you got one or more of these values wrong and you can't really figure out why, please do ask me before you go on to the practice so we can sort of correct any mistakes. If you feel good about it and you've gotten your questions answered, please do try the practice problems here. If you're working through the practice and you're stuck and you need a little bit of extra help, please don't do this on your own. Please ask for help if you need it. I'd be happy to help. Take your time on these and good luck.